Welcome back to day 23 of LeetCode grind. Solve or go home. 30 minutes, solve or go home. Alright. Rotate images. Okay, given an n by n 2D matrix representing an image, rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the 2D directly. Do not allocate in order 2D. Okay. Alan,
Oh,
why am I hearing myself, man?
because I just tuned in. Sorry.
Alright.
Wait,
Are we
better?
good now? Alright, cool. Alright, so if you're rotating 90 degrees, it looks like the 1, 2, 3, okay. So it looks like that. So 90 degrees looks like you're just shifting the element over two spaces to the right or the left, depending. So it's probably like a modular thingamajig.
Mm, kind of. But anything that you move, if you move one to three, right?
Mm-hmm.
Then where does three go?
Well, it goes to 9,
Yeah, and then where does nine go?
7,
Right, and then where does seven go?
to the 1
Right. So every movement requires that you rotate four things.
at the same time.
Yeah.
Sure. Yeah, so yeah, you just loop you do well technically okay, so basically there's only a few spots that have to rotate. So if you start position 0, 0, you know that it moves
Mhm.
around. The next one,
Mhm.
the position that it goes to, that one needs to move. And the position that one
Mhm.
goes to, it needs to move until you come back to 0, 0. Then you stop. Then you do 1, 0, and then that does the whole thing, and then that that hits everything in a 3 by 3. But in a larger matrix, it does not handle everything. So the end scenario is when you hit a square that you already visited, then you're done, I think.
Mhm.
So you need to do the top row, and then you loop until you visit it. And once you visit it, you're done with your algo.
Okay.
Yeah, I think that will handle every case. So basically, you start at 0, 0, and then you rotate until it comes back to 0, 0. Then you start at, and you go to the next one. If it's not visited, you rotate until it comes back to that initial position, and then you check the next one. If it's not visited, then you do it till it comes back, and then once you hit a visit it, you exit, and you're done.
Yeah, sure. We can do that.
Okay. All right. Sure. So if I'm doing this logic flow, okay, so basically I will need to track what index I'm flying to so that I know that I'm done when I come back to the starting index. So basically, every time I loop through this um, like swapping function, I need to have the index so I know where to stop. Okay, and I also need a visited array, so a visited index array. So basically, anything that I've edited, I need to add to visit it. Technically, I only care about the top row, but I could just add anything to visit.
What do you mean by top row?
Because only the top row matters because we don't. Once you finish the top row, wait, is that true? Might not be true. So all right. So in example two, if I do this 4 by 4, so if I do 5 first, 5 goes to the end, okay, and then 11, yeah, all around. Okay. 1 goes around 2, then you got the 9 going around, and then okay, so oh yeah, you didn't do the 4, 8, yeah, okay, so you have never mind, it can't, it's not just top row, okay, basically,
Mhm.
yeah, you still have to go through the whole array, but then you only care about the ones you visit, okay, yeah, that will work. All right, so I have a set for visited, a tuple set, I guess, visited equals set, and then it's just going to store a tuple that has the index xy coordinate.
Mhm.
Or in this case, I'm going to use rows and columns so it's easier to understand. Okay, so rows equals len matrix. Is it matrix? Yeah, matrix. And columns equals len matrix 0. Okay, given those two things, I'm going to be looping through and I'll check visited to see if it's in there, and otherwise I will run the algorithm and I'll store it to visited. So the algorithm entails, I'm probably going to use a helper function for this. Basically, I'm going to pass in the current index, and then I need to calculate the index that it goes to, and then while index is not starting index, do the same thing until you get back to starting index. So it's kind of a recursion thing, I guess. Maybe a recursion
Mm.
edge.
I don't know, but it's always a cycle of 4, right?
Yeah, that's true. So you definitely only loop 4 times. Okay, yeah, then maybe that's fine. You just loop 4 times, and you don't need a helper per se. You just need to calculate my. Okay, so the logic to calculate where it ends up is, okay, so it looks like, so in this case 5 goes to this position, and 11 goes to this position, and 16 goes here, and then this 15 goes up here. So okay, so the logic flow for this, okay, so this one, let's write it down. 0 0 goes to 3 0, which goes to 3 3, and that goes to 0 3, and it ends back up at 0 0. So yeah, okay, so it looks like you add the length of the matrix minus 1 to the row, and then you add the length of the matrix to the column, and then you subtract the length of the matrix to the row, and then you subtract the length of the matrix, the length of the row column. Yeah, so it looks like it's technically we can just build a neighbor set, neighbors in quotation mark, as in they're not really neighbors, but this position you go to, like an array that just calculates which position it's going next. Okay, wait, so that's the easy one actually. When 12, all right, let me map out the next one. So it might give me better insight. So if I go 1 0, where does that go? 1 0 lands here, which is 3 1, and then 3 1 comes to the here, which is 2 3, and then 2 3 goes to here, which is 0 2, and then that ends back up at 1 0. Okay, so this one is different. Okay. So it looks like, yeah, it looks like it's modular for sure. So when I go from 1 0 to 3 1, it's because, wait, 1 0 goes to 3 1. Yeah, how does that happen? Okay, if you're moving over, it's moving over 3, but it's trying to go here, but technically this does not exist, so you overflow downward instead. So how do you code that logic that makes it overflow downward instead? Oh, okay. So think about it. I move 2 to the right, and then that's out of bounds. So instead of moving out of bounds, I go down instead. Okay, so basically each iteration. Okay, I see. So instead of modulars, it's just quite simple. So basically, you're moving over 3. I guess technically, you try to move over 3 to the right. If you can't move 3 to the right, you move as much as you can, and then the rest of it you move down. And then the next one, you try to move 3 to the right, but you can't move 3 to the right at all, so you go down 3. And if you can't go down 3, you go down as much as you can, and then you go left. So the directionals is right. The priority is like right, and then down, and then left, and then up. You just try to fill up these priorities as you can, I guess. Right, does that make sense?
What do you mean?
Oh wait, let me try the example for this one. So it goes 1 goes to 10. So 10 tries to go to 16. It can't go right, so it's gonna go down. It's gonna go down 2, and then it can't go down anymore, so it goes left to finish it. And then this one is gonna try to go. Oh wait, no, that doesn't work because it's gonna try to go right first, which is wrong. Okay, so never mind. This logic doesn't work. How do I figure out what position it's supposed to end up at? So what is this pattern here? This one's simple, but this one is weird. Maybe if I map another one, it might be easier to look at. I do 2 0. 2 0 goes to 2 2. No, 2 3. Wait, is that 2 3? 2 0, 2 3. Did I mess up somewhere? Why does this one go to 2 3? 1 0 goes to 3 1. Yeah. And this one goes to, this one is 2 3. This one's also 2 3. No, this one's wrong. So this one goes here. Oh, that's, oh my bad, that's 3 2. Oops, flipped it around. Okay, 3 2 goes to this one, which is 1 3. And then this 1 3 goes to here, which is 0 1. And then 0 1 goes back to 2 0. Okay, so what is this pattern here? Well, it looks like it goes +3, and this one is +2 -1. This is -1 -2. Wait, that's just weird. I don't know how that gets calculated.
Okay. So you're doing the 3x3 or the 4x4?
This is the 4x4 currently.
Okay, sure. Let's look at the 4x4. Okay. So let's say you have the current location is R, C.
Uh-huh.
Okay. So let's follow where 1 goes, right?
Yeah, I did that already. It's this one.
Right. 1 is currently in position 0 1.
Isn't that 1 0? Oh wait, no. Shit, it is 0 1. Shit, did I mess up my columns? 0 1 goes here. Which one is this one? Oh, it's row 2 2 2. Wait. 2. No, that's 1 row.
Yeah, it's
row
1
1,
3,
row
right?
1,
1
1
3
3.
is right.
Yeah, I flipped it all around. So this is all wrong anyway. Wait, which one is this?
It's fine. So first of all, what is so where does this 1 come from in the 1 3?
What do you mean by where it comes from?
If let's say 0 1 is xy, right?
Yeah.
So can you make a line below 8?
A line?
Sorry, below line 8. Below line 8.
A line? What do you mean by a line?
Your code.
Oh, you mean like a blank line?
Well, you want to follow stuff along with variables. Like you're not gonna obviously trace everything, right?
Mm-hmm.
So call it comment and then x comma y, right?
Okay.
Or r comma c.
Sure. Okay.
Okay. So if this is go and then we know that the length of the matrix is 4, right?
Yeah.
Because it's a 4 by 4.
Mm-hmm.
Okay. So if you're starting with 0 1, which is r and c, right?
Yeah.
Then if you're going to 1 comma 3, what is that in terms of r and c?
Well, it looks like it's r plus 1 and c plus 2.
Okay, then if you were to change this to a different size, then would that still hold?
No, that's hard coded. So, oh, you're saying in terms of the length? So
It has to be in terms of the length, and it has to be in terms of r and c.
okay,
So
it's
let's say
r
n
plus,
n is length.
Okay, r plus n. Okay, wait. N is 4 in this case, right?
Mm-hmm.
So if it's is it just n minus 3 and c plus n minus 1 or 2?
Okay, and let's also trace the equivalent thing on the 3 by 3.
Okay, so
And if your rotation works, then it should work for every single thing.
yeah.
So let's do 0 1 for 3 by 3.
Okay. So 0 1 is 2. 2 comes here. This one is row 1, column 3. So 1 3.
Mm-hmm. No, 1 2. Wait.
Oh,
No.
is it 3? No, it's 2. It's 2. You're right. Wait. 1.
It's 1 2. Yeah, 1 2.
Yeah, 1 2. Yeah.
Okay. Does your formula now work for that?
Okay, so if I look at r comma
Where n is length. Let's say n is length and length is 3.
yeah, so if I put r plus n minus 3, c plus n minus 2. So n is 3. 3 minus 3 is 0. So 0 plus 0 is not 1. So that's wrong.
Right. So I don't think your formula is good.
So yeah, it's not
Wait. So okay. Let's not use the next one. Let's use the one after that. So where does 1 2 go after?
This one goes to 1 2 goes to this one, which is row 2 1. So it's 2 1.
Yeah, 2 1. That's right. You know that you rotate it 180 degrees, right?
Well, is it 180? It's 90 at that. Oh, you mean 180 from the first?
In 2 steps, you will go 180.
Yeah, sure.
So if you do 180 degrees, then where should you expect this to show up in any grid?
The opposite side.
Exactly. So what if you start with R and C, where should you be opposite of that in terms of n?
In terms of n, so it should be.
And n in this case is 3.
Alright, so if I'm going from RC to the 180, RC is top index 0 1. You're going to the bottom, which is 2 1. So that is okay.
And maybe it's easier to figure it out if you look at the 4 by 4 case because it's not symmetric.
Yeah, so I go from 1 to 14, right? Is that what you're saying?
No, it's not 14.
Wait.
It goes 1 to 10 to 12.
Oh. Is that 180? I guess it is.
So what is 12
Oh,
in
right, right,
coordinates?
right. That's row 3, column 2. So 3, 2.
Exactly. Okay. So if you're going from 0, 1 to 3, 2.
Yep. If I look at that. Oh, look, Danner's playing Rise of Tomb Raider.
That's great.
Yeah, okay. 3, 2 is 3, 2, 3, 2. Yeah, what is that in relation? That's just plussing the length. So it's n minus 1. And the other one is n minus 3.
If n minus 1 is 3, n minus 3 is not 2.
No, no, I mean like you add that to the RC. But I guess we don't want to add it. So it's just if we're not adding, then it's just wait. I think no. Don't we have to take RC into account because it's relative
We
to
do have to
RC?
take RC into account.
Yeah, so it can't. Yeah, so that's why I did this R plus this and C plus this, but I don't think that's correct.
Why are we plussing?
I don't know. It's just because I need something to be relative to RC, right? So you need to do an operation on RC, right? So you need something.
So first of all, anything that you do, any valid inbounds thing cannot exceed n minus 1 because that is the absolute limit.
Yes, I know.
So that means if you start with n minus 1 and you're adding some number to it, you're probably going to get above that.
Yeah.
So it should not be plus.
Okay.
So n minus 1 is the absolute limit. So there should be n minus 1 minus something.
Okay, wait. N minus 1 is 3, and this one's 0.
Yeah,
So
the
to
limit
get
is
from
3, 3, right?
yeah, to get to 0 to 3, you can either add 3, or you can. I mean, that's literally it. From 0 to 3, you can only add 3. You can't multiply 0 to get it. You can't divide something to get 3. You can't subtract.
What if you subtract?
0 subtract 3?
No, other way.
Oh, you mean 3 subtract 0? How does that help? If you're starting at R, which is 0, how do you get from 0 to 3 with a subtraction? Unless you're doing like an absolute value.
Why are we starting with R?
Oh, because it's relative to R. That's what I thought. Okay, oh, so you're saying instead you do n minus R?
Well,
Or n minus 1 minus R.
Okay, does that fit?
That in this scenario, yes. Okay, what about in this scenario? If I do n minus 1 minus R, that would be n is 3, minus 1 is 2, 2 minus 0 is 2. Yeah, so that does work in this scenario too.
Okay, so I think the intuition here is that for your first point, you're looking at things that are kind of near the starting position. So then it's just R or R and C, right? But if you're flipping it 180, then you know you cannot go above n minus 1. So it should be relative to n minus 1 at maximum, and then you do something with R, right?
Okay.
And also something with C.
So if this is R, I would assume C is a similar-ish pattern. So C is 2. You want to go to 1. So if it's n minus, well, C is 1. Yeah, so you want it to be 1. Wait, no. Yeah, so you're going from 1 to 2. Okay. So, okay, if n minus, no, n minus n, no, that doesn't work.
Okay, think about it this way. Let's say RC is 0, 0.
Yeah.
What happens if you rotate 180 from there?
Which one?
From 0, 0.
No, I mean like which matrix?
Either one. What is it in terms of n?
0, 0 in terms of n. Okay, so in the 3 by 3, 0, 0 goes to the diagonal side, which is 3, 0.
No. Rotate 180.
Yeah. Oh, is it 2, 0?
No, 180, not 90.
No, right here. 90, 180, right?
Is that 2, 0?
No. That's 2, 2.
Right. And what is 2, 2 in terms of n?
It is n minus 1 and n minus 1.
That's correct. Okay. So if you know that you're starting in the upper left corner and then you're doing 2 rotations and you're doing something with regards to n minus 1 in both locations, right?
So
does that give you the formula of what to
so it's the same thing.
RNC?
So basically you're saying it's n minus 1 minus r and also n minus 1 minus c.
Does this make sense? Or is this being pulled out of like the ass?
I mean, so if the formula works, then it works. It's just like it's hard to kind of figure out the formula without like.
Well, that's why I'm telling you to look at these specific cases. Right? 0, 0 is a very obvious case. 0, 1 is a very obvious case. And 0, 0, because it's symmetric, it's less obvious how to generalize it. But if you have 0, 1, which is not symmetric, then you can trace where the hell things are going.
Okay, sure. But
okay, so now that you have the 180 down, can you do the same thing for a 90?
Wait, 1 sec. If n minus 1 minus c, what's n minus 1 here? Is n minus 1 is 2? Wait, no, 3. 3 minus c is 1. Okay, so that does add up. Okay, so how do I get to 90?
And again, keep in mind, like, let's say you're starting at 0, 0. Like, if you do a 90-degree rotation, right, where do you end up?
Yeah. So
it's gonna be like 0, 2, right? And what is 2 with respect to n?
0, 2. Yeah. So 2 is n minus 1, and the other
exactly.
one is just
n. So it should tell you that n minus 1 has something to do with that particular coordinate.
Okay, yeah, so it looks like, okay, I think I kind of see a pattern-ish here. Let me see. So I grab this out. So this one is n, comma n minus 1. This one is n minus 1, n minus 1. And then if I go the other side, which is 0. Wait, no, it's not 0, it's 2, 0, I believe. 2, 0, yeah, 0, 0. Goes to this, and it goes here. This is 2, 0, yep, 2, 0. So 2, 0, wait, no, 0, 0 goes to 2, 0, my bad. and that's n minus 1 comma n, and then the last one is just n, obviously. So okay, so the pattern is you're going, so first 90 degrees is n, so it's n minus r, probably n minus r. This one's n minus 1 minus c, and then this one is n minus 1 minus r. This one's n minus 1 minus c, and this one is n minus 1 minus r, and n minus c.
Oh, wait. Hang on. You have too many n minus ones. Or you have too many n's, actually.
Do I?
Yes.
Wait.
So
mistake. Yeah, mistake. N is the folding. It's not n. Shit. This one. Okay, my bad. Okay, this one is n minus 1 minus c. This one is 0. 0 is not n.
0 is just r in that case.
Yes.
Right, but it's not obvious from that.
Yeah, it's not obvious. But it's
No, so that's why you want to use the 0, 1 case, so you can trace which one is 0, which one is 1.
Okay.
But yeah, this tells you where the n minus 1s are,
So,
which is very useful.
So 0, 1 goes to 1, 2, and then it goes to 2, 1, and then it goes to, where does it go after 2, 1? 1, 0, 1. This goes to here. Wait, no. 2 goes here, and it goes here, which is row 2, column 1. So it's 2, 1. Yeah. 2, 1, yeah, that one. And it goes here, which is 1.
Right, but I think you should use the 4x4 so you can more easily track the subtractions.
Okay.
So use 0, 1, 1, 3, I guess.
Alright, so
yeah,
0, 1 goes to 1, 3. Yes.
Mm-hmm.
1, 3 goes to 3, 2.
3, 2.
Okay.
Yep.
3, 2.
And 2,
then
0, right?
this one is row 2. Wait, is that row 2? Yes, row 2.
Yeah.
2, 0.
No. Yeah, 2, 0, 2, 0.
And then it goes from 2, 0 back there. Okay, so that's fine.
Mm-hmm.
So 0,
So now, if you know that which ones the n minus 1s show up in, now you have to figure out how to
yeah, okay, so
plug in where the 0s and 1s are, right?
this one is the n minus 1, n minus 1 minus c, because that's 90 degrees for sure. So this one, okay, so you go from 0, comma 1 to 1, 3. In order to get to 3 is n minus 1. So if it's n minus 1 is 3 and c is 1, how do you go from, so you need a minus 2? Oh, minus c, so you need minus 2 minus c. 4 minus 2 is 2. Wait, no. 2. Wait, no. That's wrong. What am I talking about? Okay, wait, hold up. So,
No, so it's always n minus 1 is where you start. You cannot do minus 2.
Yeah, wait. N minus 1 minus c. Wait, am I confusing myself here? Why is it? Okay, n minus 1 minus r and n minus 1 minus c is how you get from 0, 1 to 3, 2, right?
That's right.
Yeah, but that's okay. Yes, right. Because n minus 1 is 3. 3 minus 1 is 2. Yeah, that's correct. And then n minus 1 is 3 minus r is 0. Okay, that's fine.
Oh, okay, that's so you know the left coordinate has nothing to do with n minus 1.
What do you mean?
In line 7, n minus 1 only shows up on the right coordinate.
Line 7?
Mm-hmm.
Yeah, I know.
So don't use n minus 1 to represent anything on the left side. What is 1 in terms of 0 or 1?
It's 0 and it's plus 1. Well,
Okay,
it's
if you
r
have
plus 1.
0 and 1 and you try to make 1, which one are you going to use?
If you have 0 and 1 and try to make 1,
Hmm.
which one are you gonna use? What does that
Or
even mean?
how many zeros and how many ones do you use to make 1?
Use 1, 1.
Exactly. So it's just C, right?
So you're saying it's just C?
C is the left coordinate.
Okay, that's weird. Okay. N minus.
And then on the right side, you have n minus 1 to start with, and then how do you get 3 in terms of either 0 or 1,
N minus 1 is 3. So how do you get
right?
from 1 to 3? You need a. You
No,
need.
no, no. How do you get from 3 to 3
It's not.
and subtract something?
Wait, what do you mean? How do you get from 3 to 3? What do you mean?
So you have 0 as R, 1 is C, and then you have n minus 1 is 3,
Yeah.
and your final number is 3, right? So n minus 1 minus something gets you 3.
Oh, 0.
Exactly. So
So
it's
that's
minus R,
R.
right?
Yeah. Why is this? Why is this flipped?
Because you're rotating stuff. When you rotate 90 degrees, your rows and columns flip.
Oh, that makes sense. Okay. Okay. So from this one to this one, so you're going from 0, 1 to 0. So if I'm going from 0 to 0, so it looks like this one's just C also, because it looks like you just go from 0 to 0. And then this one you're going from 1 to 2, so that is okay. How do I get
Wait, what? Oh, no, you know C is 1. How can 1 equal 2?
Oh, you mean
Doesn't
I
make
mean R. I mean R. Sorry.
What? You mean the right coordinate is R,
Yeah.
not the left.
The right coordinate is R. How do I get from? Okay, so I have to get from 1 to 2, and that was already solved earlier. It was N minus 1 minus C.
Okay.
Because N minus 1 is 2
Okay.
minus C is 1.
Okay. And does this check out, by the way?
What do you mean by checkout?
Does it make sense?
So far
Not really, right?
it doesn't look
But,
like a pattern that is
no,
recognizable.
okay. So here's the pattern, right? To get 180 degrees away, you n minus 1 minus whatever you started with.
Sure.
Okay? So this works between RC and n minus 1 minus R, n minus 1 minus C, right?
Mm. Did you say something? I said mm-hmm.
Okay. So if we know that is true, so if you start with R comma C and you end up in n minus 1 minus R, n minus 1 minus C, right?
Yeah.
So then if you start with C and n minus 1 minus R, if you take n minus 1 minus those arguments, do you get the same thing when you rotate 180 from that? So basically, does line 11, if you take n minus 1 minus each of those guys, become line 13, and vice versa?
You're saying okay. So you're saying do N minus 1 minus C and then put that as column instead?
No.
No. So, okay. So the coordinate of line 11,
So
right?
the row, sorry, the left and the left side of line 11, when you take n minus 1 minus that, should become the left side of line 13.
Yeah, because you're kind of flipping it, right? So.
No, well, your 180 minus, oh, sorry, 180 degree rotation means that it's n minus 1 minus the first
Oh,
time.
so you're thinking of terms. You're thinking of terms of 180 rotation in each direction. So
So you
from
know
a
that the
90
180
degrees
rotation,
with a 180, you're going to the 270 direction. Is that what you're saying? So you
no, no,
apply up 180 to a 90.
if you apply 180 to 90, then you'll get 270. That's correct.
Yeah. So that means You're just applying the 180 logic to 90 to get to 270.
Right. And if you do get the same number, then you should be convinced that it works.
So basically, what you're saying is, given 90 is C and n minus 1 minus r, if I apply the 180
The
to
180
it,
logic,
that means
which is
it's
n
n
minus
minus
1
1
minus.
minus r minus C. And then
No. It's n minus 1 minus the argument,
n
right?
minus 1 minus.
So compare 0 to 180. Sorry, compare the original guy to 180.
Who's the original guy?
Uh, RC.
Okay. What do you mean by comparing to 180?
So if your input is R comma C,
Yeah.
and then you do a 180 rotation, and you get n minus 1 minus R, n
Yeah.
minus 1 minus C, what is the transformation?
What is the transformation? Well, it's yeah. I don't understand what you're saying.
Okay.
Isn't the transformation just n minus
So
1
if you
minus
don't do anything, if you don't do any rotation, your RC is RC, right?
Yes.
Okay. So can you write that down?
Okay.
Okay.
Yep.
Now, if you do a 180 rotation from this RC,
Mm-hmm.
what is your final coordinates?
That's n minus 1 minus r and n minus 1 minus c.
Okay. Then from this, what is the transformation to do 180?
So if I'm doing 180 on the next one,
No.
oh, you're doing
If
one
the input is
n
R
minus
comma
1
C,
minus whatever's in this position.
exactly. Okay. So now replace those positions with the 90 position.
Okay, so if I'm using 90, it's c and n minus 1 minus r. Then this would be n minus 1 minus c.
I wouldn't delete that just so you can be. It's very obvious that you're matching it.
Okay, fine.
Oh, but sure. I mean, if you can follow along, then that's also fine.
So this becomes n minus 1 minus c, and this one becomes n minus 1 minus n minus 1 minus r.
Okay. And what does that work out to?
Okay, n minus n cancels out.
All of that's in parentheses, by the way. So
Okay, so is it like wait. Yeah, so it's n minus 1 minus n minus 1 minus r, right?
Mhm.
So if that works out, you distribute the negatives, you get n minus 1 minus n plus 1 plus r. And then the n's cancel out, the 1's cancel out, it's just r.
right. Does that match line 17?
Yes.
Okay. Then are you convinced that this rotation works?
Yes.
Assuming that the 180 logic holds.
Yes.
Okay. Then that's it, right? So now you have a cycle of 4 things for every coordinate.
Mm-hmm.
In terms of the original coordinate.
Okay, so yeah, so basically it's this starting location of you start off RC, then you go to this one, and then you go to this one, and then you go to this one, and then you end up back at RC.
Right. So basically, if you're at RC should map to C n minus 1 minus R, and then C n minus 1 minus R should map to 180, and then the 180 should map to the 270, 270 should map to the 0, right?
Yeah, so this is 0 to 90 to 180, 270 to 360. And 360 is just 0. But then you have to go back to it to put it in, right?
Right. So I mean, I think you've already done the heavy lifting here. So it's pretty much for each thing you just map this to the next thing, right? And then maybe have some kind of temp thing that stores what your original guide was.
Yes. So yeah, given this array, basically, what technically you don't want to do the first. You don't want to do RC because you're already on RC. So you start at 90, I think. You just need to. So you start the array. No, you're in the loop. You check if it's visited, if this coordinate is visited,
Mm-hmm.
and if it's not, you store the temp value. Then you loop through the neighbors array, whatever neighbors, and then you pull out that index. You pull out that index into another temp. You store this temp into that one, and then.
Well, I mean, do you need to? You know, the index is just that index plus one, right? Assuming you don't go beyond.
What do you mean by that index plus one?
It's always in this order.
Um, what do you mean by
So
that?
if your, let's say, neighbors array has these four elements,
Yeah.
right? If your neighbors of 0, you should go to neighbors of 1. If you're neighbors of 1, you should go to neighbors of 2, etc. Right?
Okay, so you're saying instead of looping, you're just accessing each index?
Uh, sure.
Okay. Does that do anything for you?
But the tricky part is like to overwrite stuff. You either have to write them all at the same time, or you have to make a temp variable that stores one of them, and then you shift everything over, and then you replace with a temp, right?
Yeah. So that's what you do. You need to replace stuff.
Right, right.
Yeah. So if I loop through this array, kind of,
Mm-hmm.
you pull out the value, you
Mm-hmm.
plop in the temp, and then yeah. So and then the next value, the next temp is used in the next location. Isn't that basically what you're doing? Unless it's something else.
No, no, no. So let's walk through an example. Let's use the 1, 10, 12, 13 example, right?
1, 10, 12, 13.
Right. So let's say your neighbor's access gets used 1, 10, 12, and 13, right?
Yeah. Yeah.
Okay.
So you start here.
So what should your algorithm do when you replace things, right?
You start here, right? So you have the
Okay.
one, you store it,
Mm-hmm.
then you put it in.
Right. So temp is 1. Temp is 1.
Temp is one, yeah, and then you come
So
here.
then 10 is 1.
So yeah, you look at this, you you pull this out first. You store it into another temp, and you put this one into here. Now the temp is 10. And you look here, you pull this out, and then you store 10 into here. And then you look here, and then you pull this out, you store 12 into here.
Okay, so you're overriding temp every time.
Yeah, is there like another way
Okay.
to
No,
do it?
that's totally fine. Um, but what happens? I guess. No, 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 it's fine. Actually, it's fine. Never mind. Yeah, I think that'll work.
Wait, then what was your way of doing it?
Uh, well, you just need to do temp once, and then you shift everything over,
Yeah, but how do you
right?
shift it?
So let's say the last guy is 13. So let's say temp is 13,
Yeah.
right? Um, and basically replace uh. So if temp is 13, then replace the position of 13 with 12, replace the position of 12 with 10, replace the position of 10 with 1, and then now you replace the position of 1 with 10.
Wait. All right. So you're saying you started at 13,
Mm-hmm.
and then you just put 12 into here?
No, no. So you store 13. You're like, oh, I
Yes.
need to
Yeah.
remember
So you
this later.
stored this one, okay, and then you're just pushing this over to here. You're pushing this over to here, pushing this over here, and then you push this back into here.
And then you put temp at the end. But it's fine. It's literally the same thing. It's so
It's
whatever
just
is easier for you to follow, just use that
it's
one.
shorter code because you don't have to have two temps. You just need one temp. who
No,
it's
no, no. So you don't need two temps actually. You just need one temp that you overwrite multiple times. So what
no,
you're
no,
doing
no,
is
but
just
then you don't you technically need to store the new one too in my algorithm. In yours, it doesn't look like you need
no,
to.
no. In your algorithm, your new one is just whatever position you're currently at, right? So if you're at one, then your temp is none, right? And then if you're at 10, then your temp is 10.
No. Okay, I know how to code mine. It's just not that great.
But then code it, right? Like you're, I mean, the minimum requirement is functional stuff, and then you can optimize it later, right?
Yeah. Okay.
If you don't even get the functional thing, then that's minus a lot of points.
Yeah. So temp, you get the first element. So it's matrix. Um,
And then I'll teach you a Python like cheater cheat sheet method where you can literally swap all four things at the same time.
wow.
You don't have to have a temp.
That might be next time because I'm running out of time.
No, I mean it's short. It's just one line. If you say A B C D equals B C D A, that becomes like that's literally what you do. It's really dumb.
All right. Okay. So temp. I'm gonna pull out the first index. Wait, actually no. The temp. Wait, if I'm starting from here. Okay, I want RC as the start, so I'm just gonna do RC.
Yeah, you can say temp is RC. No, temp is neighbors. Or sorry, no, temp is matrix of RC, right?
Yeah, matrix of neighbors. Oh, actually, it's not neighbors. It's just straight up RC. Matrix RC. Okay,
Okay.
but that's yeah. Okay, temp is that. Okay, wait. Before this, I want to check if it's in visited. Let's see. Let's pull this down here. If R, so it's a for loop for I in row and rows. I guess R because we're doing R. C.
Range.
Oh yeah, range. Yeah. Range. Wait, is it range or range len?
You already have len. Line 24 has len.
Oh right. Okay, never mind. Okay, my bad. Okay, so yeah, so for R in range R. Okay, if R C not in visited, then I
Then you do
execute
this
the
thing.
code. Yes. So given that, then I get the neighbors, and then the temp. So neighbors is this, temp should be RC. Yes. Okay. So now that I have the temp for neighbor and neighbors. Okay. So for neighbors and neighbors, I do. Okay, so I need to grab the new temp. So temp 2 equals.
You want neighbor R or neighbor row, neighbor column in neighbors.
Oh, just to pull them both out.
Yeah. Then it's easier. Otherwise, you have to do access of 0 and 1 and stuff.
Okay, so this, yeah, so this one would get me the first one, which is this, the 90 degrees one. Okay, so I need to store this, the value of this, temp 2 equals neighbors, but not neighbors, matrix, neighbor R, neighbor C. So now that I've stored this, now I can do matrix neighbor R neighbor C equals temp.
Yes. Yeah, that's fine. Yeah, that's actually fairly clean, actually.
Except I misspell stuff. Okay, equals temp. Then I need to store this into visited. Visited dot add
No, you can do it at the end.
Okay, sure. Okay, so now that then I just replace temp equals matrix. So temp is
No,
now
temp
temp
equals
two.
temp two.
Yeah, temp two.
Yeah.
I already had that. Okay, and then yeah, that's fine. And then I need to add visited. Okay, so I visited this
You visit
one.
all the neighbors.
So I just yeah. So but I'm in a loop, so I might as well add all of them here, right? Unless you
Oh,
guys are you just doing visited that
no, no,
add
that's
in
fine. That's
array?
fine. That's fine.
Okay.
No, that's fine.
So I'm gonna add the tuple of. So I'm needing to add the index, right? The index is what I'm looking with. So it's RC is not okay. Yeah. So I'm adding indexes. So I need to add in. So literally just the tuple of neighbor R neighbor C.
Yeah.
Okay. So I added to there, and then this will do all the looping and replacings. And then when I get to here, it's done. It will do the last replacement here, and then that should finish it. And then because this is a loop, temp will always reset at this point. Okay, that's fine. Temp 2 always reset too, so that shouldn't have old stuff. So I think that will.
Oh, I see. Yeah, that's fine. So now you should print.
Yeah, I should print it. I'll print it each loop, I guess. I'll print it here.
No, it says don't return anything. Just print.
Oh, it's no returns. Okay.
Or try to run the code, I guess. If you run the code, it will show you the output anyway. You don't need to print.
Okay, so I messed up somewhere. Oh, oops. Don't print. I mean, if you don't print, you don't see the operations in real time, but I guess it's fine. Did I just mess up again somewhere else? And, oh, n is the length. Oops. I guess I could set it up here. Oh, n is literally just len matrix, or just rows, right?
Oh, technically all of them are just n. Think about it.
What do you mean by technically all of them?
Rows, cols, and everything is n.
What is? I thought it's n by n matrix. Oh, it's n
It's
by
n
n.
by n.
Oh, okay. So it's always okay. Never mind. Yeah, doesn't matter. I just do rows. Okay, that removes all the n's. I think that's fine now. Let's see. Okay, yeah, it swapped it. And then this one. Let's grab this one. Look at this. Alright, looks good.
Okay, very good. This is a yeah. It's mostly logic. It's kind of tricky, but you have to work through it.
Yeah, the hardest part is solving the pattern. The code isn't too bad.
Yeah, which is why I tried to guide you towards like how would you identify that.
Yeah,
Oh,
I
it's
couldn't
in terms
figure it
of-
out from that long. And then when you said 180, basically once you solve, because 180 is the easiest one to solve, and then basically you're saying the rest of the indexes are based on 180. If like how do you get from 90 to 270 using a 180? And it's all you're just using the formula of 180 to get to 270, which makes sense.
Right. I mean, either you have the intuition to look at it, or you look at the pattern and say like, oh, it goes from 0 to 2, and like, what the hell is 2? 2 is 3 minus 1, right? So, you have to kind of look at it and be like, oh, if I'm very close to 0 on this side, I'm going to be very close to the length of matrix on the other side, right? So that's kind of the intuition that you would use to derive these things.
Okay, cool.
Okay, nice, very good.
All right, do you want to share your Python crazy shit real quick?
Oh, I mean, it's fine. Basically,
Oh, just you can. Oh yeah, if it's too difficult, you can just paste it.
no, it's not difficult.
Okay.
But basically, you would say something like for neighbor and neighbors or something. You would have
So using the same neighbors code that was generated.
yeah, it's
Okay.
so you still need the line 16, but
Okay, so what do I
basically,
do?
in Python, you can say a comma b equals b comma a. That swaps those two things.
Wait, so for neighbors and neighbors, I do a comma b equals b comma a.
No, so you would do something like neighbor. Sorry. No. You would do something like neighbor 0, comma neighbor 1, comma neighbor 2, comma neighbor 3 equals neighbor 1, comma neighbor 2, comma neighbor 3, comma neighbor 0, or something like that.
Oh, so
Yeah,
you're saying
you
this
don't need
index
to for.
equals this index equals that.
Yeah, and then they just literally swap them off. So
Wait,
it's really
wait,
stupid.
wait, so you're saying neighbor.
No, try it in the console, right? Like if you type like a equals 5, b equals 10, and then you type a comma b equals b comma comma a, and b becomes 5, and
Wait, how
a
do I
becomes 10.
try it in console? Do you mean like just run it
Oh,
here?
you know Python console?
I mean, I don't. I could have it. I just
Okay,
don't.
fine. Then I'll just send you the code after. But
Yeah,
like,
all
it's
right.
fine.
I'll look at
Yeah,
it. But all right, cool.
yeah. No, this is a good problem.
Yeah, I never solved this one, so it's definitely good to practice. The pattern was super hard to figure out for a while. I was just confused.
Yeah, no worries.
All right, thanks.